I am Mahendra and today's topic is dynamic memory allocation. Why we need dynamic memory allocation? In C, default memory allocation is static in nature. It means if we don't specify which time we need memory, then it is allocated at runtime. And there are static memory allocation. Usually we do static memory allocation through arrays. And dynamic. In static memory allocation, we use arrays, and at the time of declaration of an array, we have to specify its size constant all the time. And after specifying constant size, for example, suppose X is an array, its size is 100. Its size is 100. And we want to store n elements in this array. Then what happens? N may exceed this 100 size. It is always constant. It means number of elements are more and memory locations for integers are only 100. And another situation, if n is suppose 15, it means rest of the 85 locations remains unused. These locations remain unused. So one problem is problem of overflow and other is problem of underflow. To overcome this problem of overflow and underflow, we use dynamic memory allocation. It means memory allocation as per the demand. Memory allocation at the time of execution. So formally we define dynamic memory allocation as memory allocation at runtime. It means we can allocate memory, we can have memory as per the demand, as per the requirement at the time of execution. Now, how we allocate memory dynamically? So don't worry, C language provides 4 dynamic memory allocation functions, and these functions are: first function is malloc, second Calloc, third is realloc, and fourth function is free. And all these functions are being supported by this library stdlib.h, standard library.h. It means if we want to use these 4 functions, we have to include in our program stdio.h header file. So in nutshell, static memory allocation, that is through arrays, and it is at compile time. And dynamic memory allocation is at execution time. The basic difference is that. So now we are going to start one by one about these functions. There are four functions, four dynamic memory allocation functions. First two functions are for allocating memory. And the third one is for reallocating memory. And the fourth function is for releasing the memory if it is no longer in use. Now first function, malloc. The syntax of malloc is, we call malloc function and expression for the size of memory in bytes. Here memory measurement is in bytes, and after allocating memory, if you are requesting some memory slots, then malloc allocates that memory and returns address of its first byte. Return address of its first byte in form of void pointer. Then why it is in form of void pointer? Because actually memory is allocated. Suppose malloc, and here we write 25. It means malloc will allocate, if possible, 25 bytes of memory. This is 25 bytes of memory in contiguous fashion. And all the memory locations are adjacent to each other. And it gives, how we know that 25 bytes memory is allocated by malloc. It means malloc gives address of its first byte, and all the bytes are adjacent to each other so that we can traverse very easily. We need only address of its first byte, first location, first integer location is this, and we need only this address. So this address malloc gives in form of void pointer. Why in form of void pointer? Because up to this time we have not decided which kind of data we are going to store in this memory location. The memory content is not decided yet. We are simply requesting for memory, and that memory is being allocated by malloc function if it is possible. All the time it is not possible to that malloc is serving us successfully. Then there is some provision. We can check whether memory is actually allocated or not. If memory is allocated, then we get address of this location, its first byte where it starts. If memory is not allocated successfully, then malloc simply returns null. So this is the purpose of void pointer. Address, and pointer is a container of address, so pointer is needed, but we don't know about the object, which kind of object we are going to store here. The content, malloc is not concerned about this object, so it returns address but in void pointer form, so that it can be casted to any type. Void pointer is a general purpose pointer, or we may say generic pointer, that can be casted to as per the requirement. For example, if we want to store n integers, when our program executes, we put the value of n through keyboard, we input n through keyboard, and that n may be something. Suppose I run first time I can give 15 and second time I can give 55 and so on. The n can vary. It means we are by using malloc we are achieving memory at execution time. So suppose we want to store, we want to allocate n integers locations, so we simply write n into size of an integer, that is data type is int, simply. This n we provide at the time of execution, so it is clear that we can have memory at time of execution. And now we can use cast operator to cast this address. It is address. This address can be casted. Now we have decided that we are going to store integer here, so that's why we are free to cast it like integer pointer. Now second function, our second function is calloc. Calloc is also used for memory allocation. Calloc stands for contiguous allocation, and it is also used for memory allocation. Then what is the difference between malloc and calloc? Actually malloc allocates single block and calloc allocates multiple blocks. Multiple block. Now syntax of calloc is calloc number of blocks and size of each block. Obviously, in the same manner, it also returns the address of its first byte in form of white pointer, and as per the demand and requirement, we can cast this whichever type of pointer we want. For example, if we want to store floating type data, then we can cast it this white pointer address with float pointer by using cast operator. And calloc, suppose m floating point numbers are there. Suppose I want m blocks and we want to store floating type data there, then size of float, it will work. Now third function is realloc. Realloc function is used to reallocation of memory. It means if memory is not sufficient, memory is not up to the date by malloc or calloc, then we can update that memory. Okay, if you want to change, we want to expand or shrink that memory, then we can use realloc function. Now fourth function is free. In free function is used to release the memory so that it can be used for some another purposes also. If our purpose is solved, then we have to release that memory. So free, and syntax of free is free and the pointer of its first location. Now let us have some problem so that we can clearly understand what is how we use malloc or calloc. So now let us take very simple program for finding the sum of n integers. Very simple program. In first program I'll use malloc, then I'll use calloc. There are n integers. We must declare a pointer for sum. I am taking one variable sum and initializing it with 0. Simply I am putting on one message. Enter the value of n. By using scanf, we are entering the value of n through keyboard. Now we are calling malloc to serve. Then n integers are there, and size of one integer is, by using size of operator, we can have like that, size of an int. So it will give the size of one integer, and there are n integer. So in this expression ultimately give the size of all the n integers. Function is called, and address here, address, malloc returns address, and that address I am casting here into pointer, and I am storing that in P. Now we can input all the n integers. So we can use one message here. Now input the values of all the n integers. I am taking one loop. Address of its first location is P, and now we can use pointer arithmetic. We can have P plus C. First time our data goes to first location, which address was in P. Second time, P means P plus 0. First location, second time it goes to, it advances, pointer advances to one position, and in the similar manner we are putting data through keyboard. And now I want to calculate sum, then sum is equal to sum plus. Now P plus C is the address, P plus C is address, and star P plus C, that is data at address, data at address, data or content at address P plus C. This content, suppose this is P plus C, this address, then it is, the content is denoted by P plus star P plus C, in direction operator we can put. So then we are putting star P plus C. Yes. Now we can finally calculate. The sum is sum. So we have seen in this that we can have memory dynamically as per the demand as execution time. We can also use calloc function here. In calloc we have to mention size of, here we are finding sum of n integers. It means for one integer takes maybe 4 byte or 2 byte, depend on the system, and there are n integers. It means n integers, n block is there, and size of each block is size of int. Only the difference here in malloc, in case of malloc, we have used star here. And now at this time, it is taking two arguments. First argument is number of blocks and the second argument is size of each block. Rest of the things are same. And one major difference between malloc and calloc is through malloc, if you are requesting memory through malloc, then memory is allocated and all the locations are filled with garbage values. And when we use calloc, all the memory locations are filled with 0. And now it's our moral responsibility to release the memory free so that it can be used for another purpose. So in conclusion, we have seen that by using dynamic memory allocation, we can overcome the problem of overflow and underflow in case of static memory allocation we were facing. So dynamic memory allocation gives a lot of opportunity to save memory and have memory exactly as per the demand. Thank you.